You need to participate. And so for those who solved, uh, what is the reaction VA? What is VA and VB? Yes.
You can start by finding the support reaction from NA and B.
Sorry, I lost you. Find the what?
Reactions at A and B.
Are you sure you can do that?
Yeah, when you have the distance and the UDF, you can take moments to one side, say to at point A, then calculate the support, the reaction at B, then use the sum of forces,
My friend, do you understand what
upward
is
forces also the
statically?
downward force, then you find the reactions at the other end.
No, that's not possible because this is statically indeterminate. We cannot do that. This is a statically indeterminate structure. So the first step, if you remember, you need to make it statically determinate. So he has tried, but unfortunately, that's not right. Well, I told you when you choosing what to do, you need to make it simple. Now, when you make the reaction redundant there, it means that I just need to walk you so you can see what you're saying. So that's A, and then there is a so you remove uh, the load, and then you create a moment there. You think that is easier to solve? Okay. Anyway, make A and B the moments. Make MA and MB redundant. Redundant. That will reduce this to a simple statically determinate structure that you can solve. So the result for that, please brace yourself for the, you need to participate. So once you do that, then this is a simple statically determinate structure. First, you need to be very clear on what you're doing. Uh, so you have chosen the A and B, and what does that mean? That means that we have this. Uh, we have a structure like this, and so then this you can solve uh, using the various methods that we had proposed. So this is after making it redundant. But what do you do? So this is your this is the primary structure. So and the so this is A and that's B. And please note, because I'm using this platform, but I'm going to delete after I finish working out. such that this is the theta A there. Of course, theta A, if you draw some nice tangent there, and also draw another tangent there, you have theta B. So basically it means in this, so this is your primary structure. After reducing the structure, after removing the redundancy. But this is just to make it simple that you're able to solve. So to make the structure complete, then you have to also add the redundancies that you have removed before. So plus, what is I told you need to participate. What is structure plus what? Because this is, we have made it simple to make it easy to solve. But the original structure meant that we have ignored which two things? By changing the supports to a pin and this roller, what have we done? Hello? Indeterminate structure. If you check, this structure has a VA here. There's a reaction, there's a potential reaction there, and there is a moment. And also this here, there is a reaction there. There's supposed to be a moment there. And of course, by common sense, these ones are zero because can only have a horizontal reaction if, for example, the load was at some angle. That's one option. Or if there was or a horizontally externally applied horizontal load, which is not in this case. So in this case, we only have four reactions. We have four reactions and three equations of equilibrium. So this structure is statically indeterminate to 1 degree because the reaction is the vertical VA, okay, VA and MA there, okay. So VB and MB. So the horizontal reactions we have ignored because it's not possible based on the nature of the loading. If there was a load to some angle which is not vertical, then we can have horizontal reactions. But in this case, that's not true. So then we have four reactions and three equations. What does that mean? So to solve, you choose whatever redundancy actually you can remove one or two. Now in this case, it's easier to remove two redundancies to make it easier to solve. Someone I see here saying why one is a roller. You can put a pin for you know that if this is to be, if you put a pin in at both ends, uh, this would be able to take VA and HA at the same time. VA and HA. But because then that would means this structure would still have four reactions, and then it would be meaningless what you have done. So the easiest way is to make one a roller. To make it statically determinate, one has to be a roller and another one has to be a pin for the one who has that question. So okay, that's the simplest answer. Actually, it's even much simpler than that, but that is the simplest answer I can tell you. So when you make it statically determinate, you cannot put pins, two pins at one end and another end, because a pin means there is two reactions 2 reactions, 4 reactions, that means you will not have solved the statical indeterminacy. So can you see my screen? No? Can you see my screen? Can you see my screen? Hello?
Yes.
Okay. Please make sure you can see my screen. Whiteboarding, now there is an option for push to, now there's an option down here. There's usually some option down here. There's usually some, where is it? More option settings, whiteboard change layout. General. Now this is going to be very difficult without a way to write. There's usually some icons down here. I don't know. Whiteboard open jump. What does that mean? that's not what I need. There are usually some tools to write. I don't know how to access them. Usually down here. Yeah, this one, no? No. Settings, troubleshoot, report abuse, turn on captions, play visual, open picture, change layout, open. What does that mean? Certainly. Okay, can you see the whiteboard? Hello? Okay, can do this. Share. Can you see the whiteboard? Hello? Yes? Please respond because we seem to have wasted a lot of time. Hello? Can you see the whiteboard? Yeah. Yeah, okay. So we move on swiftly. And what you were doing, what you were saying, how to solve this problem. I said that you remove the redundancy. Once you remove the redundancy, you why? Hey, now I can't try it. Well, okay, here. So yeah, so and I need you to participate so that so this is your original structure. That is your original structure, and then this is and then and this is 30 kilonewton meter, and then this is 3 meters. So like I've said, we have to decide the redundancy, and we've decided, okay, so this is A, I believe. Are there any other colors? Yes, okay, good. And So this is B and this is A. So you make it redundant by someone was talking about pin, or if you want to make it statically determinate, at the grand scheme of things actually it doesn't matter, but you need to make one pin and another one a roller. You can make the pin, the two pin is fine because you still can solve, but the principle, it will defy the principle a little bit. Because if you put two pins, then the structure will not be statically. If you don't know that if there are no externally applied horizontal loads with the pin, then the horizontal reaction on the pin is zero. It would give you trouble to solve. But even if there are two pins and you understand that principle, still you can solve. But to strictly to the sense, then this is the way to make it structurally determinate. So so if we are to draw the bending moment diagram, not sorry, the deflected shape, and you are to draw some nice curves there. So this would be theta A, and this is theta B. I will have to delete this because you can see the board is very very small. So this is the primary structure. This is what I wanted to say. Primary structure. Primary structure plus uh, this is now the principle of superposition. We have made the structure statically indeterminate by doing what? By removing, for example, MA. So still you have to add. So plus you removed MA. So maybe let me try to choose a different. So if you are to draw the again, now here you have to apply the moment that you removed MA. Of course, here now this load will cause theta A, but the moment MA also will cause some deflection there. Let's call it theta A, and theta B, and then this is theta B prime B. Now, just to get it over with, you remember Maxwell reciprocal theorem that if you put a unit because to be able to solve this, we will apply a unit moment at point A. So theta A in the grand scheme of things theta A in the grand scheme, so theta, sorry, not theta A per se, let me try to erase this. Theta A prime in the grand scheme of things would be the moment times alpha AA, and alpha AA is what? Alpha AA is the, seems quite difficult to write here. The challenges of technology. So the moment A times alpha A. Please not, because I'm going to delete all this. And then theta prime B. Anyone? Actually, I forgot that we should be participating. Theta B, how do you get theta B? So just to be clear, this is theta B due to theta A, the gradient at A, due to a moment at A. And of course, so let's call it theta AA. And then there will be theta BA, because the deflection at point B due to a moment at point A. So let's call it theta A. Anyone? We've been in this class long enough. Anyone else? Anyone? How do you calculate theta BA, theta prime BA, based on intuition? I mean, from what we have, the first part. Faith Chepkoech. Faith, please tell us how to. Is Faith in this class? I can see. Yes? Class rep. Uh, Baridi. I don't know. Why are people not responding? Okay, coin list. Speak. Now I need you to speak. Yes, someone is typing strange things on the keyboard. Please speak. Someone please. I want to hear the voice, not the keyboard. Oh, I have to unmute you to speak. Who is this? So you can raise your hand. Whoever wants to speak, raise your hand. Then I unmute you. Okay, let me use an alphabetical order. Not all. Okay, the list that is there. No, that's not right. I don't even know what happened. You should be able to unmute yourself, I think. Turn on the microphone. Okay. Yeah. Yeah, you can unmute yourself. Yes. Caroline was just speaking. What are you saying? You unmute yourself and speak.
Moment at A,
Yes.
alpha BA.
Yeah, that's correct. So alpha moment at A, then alpha at B. That means the flexibility coefficient at B. After you speak, you can unmute yourself. Okay, that's good. And then now, the second part of this is now you apply the redundant. You apply the redundant at B. So the probably this is the so again using the same principle, you apply the moment at B, and then this would be theta B. So that to make it a little different from the previous theta, so let's call this theta BB, and again this would be theta at A due to unit due to moment at B. So this is again here. This is so how do you calculate theta AB? Anyone else? Theta prime AB? From the principles we have already established. Anyone else? Anyone else? Odiembo. Alphras Odiembo. Please unmute yourself and speak. Then you mute yourself back. Alphras Odiembo. Unless you're not in this class, in which case I will have to. You need to participate, eh? Yes. No, Baridi, speak up. Don't be like a keyboard bully. Speak up. Don't just speak. No one is going to unmute yourself and speak. Baridi. Yes. Speak. Okay. Moment at A. No. Where is the moment at? Yes. Times alpha. Uh, uh, alpha AB. But in fact, alpha AB and alpha BA is the same. But the correct one is alpha AB. Okay. There's someone wants to join the class. Why are people joining so late? Okay. And theta BB is should be easy now. Is theta BB is anyone else? Rumbura. Tony Rumbura, how do you get theta BB? Hello? Yes?
Theta BB is moment at B times alpha BB.
Yes, times alpha BB, correct. So then you finish. I need to recapture so that you. So once you remove the redundance here, you have removed redundant at A at the moment at A, MA, and MB. So this becomes your primary structure. Now you solve that structure. Now to actually to solve this, you solve this structure, and solve this, and now add the 3. Then you'll be able. At the end of the day, you'll have only MB and MA as unknowns, and you're able to solve. In fact, as this structure is, you are able to solve each individual each individual structure on its own and then add. That is why we are talking about the principle of superposition. So out of this, just to explain a little bit more, so this is a primary structure. So here you apply the redundance, apply redundant. It would be difficult to write, so allow me to just write R redundant MA, yes, and solve. So choose. If you once you're given a structure, it's your job to choose which choose the redundance. That's the first thing. That's the key. Choose the redundance. Once you choose the redundance, can be 1 or can be 2, but the redundance should be able to make the remaining structures easy to solve. That's the principle. So once you choose the redundance, solve the structure without the redundance, then apply the redundance one at a time. So here we have applied RMA, and here now apply the other redundant. Apply sorry, apply redundant MB. Okay, so then at the end of the day we have equations that we can solve, and just to, because the interest is that you understand. So actually theta A plus theta A prime plus because the original, if this thing were to deflect because of this is 90 degrees, so that means the deflection, the eventual theta, they actually theta B is 0 and theta A also has to be 0. That's the condition because of the way the support system is. So just to create two equations. So actually theta A, I give you the first equation. The equations that have to end up there should be in fact theta A plus theta AA plus theta AB must equal to what? Hello? Must equal to what? Anyone at random? Must equal?
0.
Yes. And so I will not write because that would seem to be too much writing. So I just go straight to the substitution. So 0 must be equal to theta A plus MA alpha AA alpha AA plus MA alpha AB alpha AB. Similarly, using the same logic, then 0, because the other end is also fixed, must be theta B plus MB alpha BA plus MB alpha alpha BB alpha BB. Okay. Now this alpha BA from reciprocal alpha BA is the same as alpha AB. You can determine this. This you can determine from a solution of structure. The primary structure. This one can be determined. This one alpha BA equals alpha AB, which can be determined from any method, but I think I really find the energy method very easy to use to solve this one. And also alpha BB and also alpha AA can be easily solved. Sorry, alpha AA I think is good as I mean alpha BB and alpha AA, and all this can be easily solved by the energy method. So I don't know which method you choose, but again, for me, I find the conjugate beam pretty easy, pretty simple. So solving the first structure, you need to be a little. Please put your calculators around. I'll be asking you to solve. I think the only difficult, not difficult, I would say, the involving would be the first. Actually, simple, but so you load the if you use conjugate beam, I prefer conjugate beam. You can choose your own method. No, just a minute. So here, no, here in the conjugate beam method, you load the conjugate beam. Fortunately, the conjugate beam, the conjugate of either a roller or a pin is the same. Then you load the beam with the M over EI diagram, which you can solve here now. I think we can do this pretty fast. What is VA? Please, these are good, should be good structural students. So this is just to make it easy to you, easy for you. So this is 3 meters, 3 meters. and this is also 3, and this is 30. Good structural students, what is VA? VA and VB. Pretty fast. I will wait. This is 30, so okay, let me see. VA plus VB should be 30 times 3, it should be 90. The first thing, you can sum moments at if you sum moments at A, so summing moments at A would make 30 times 3 times 3 over 2, assuming that is positive, so this is positive, then that means the other one is minus 6 VB is 0. That gives VB as what? 90 over 2 over 6. That gives VB as
22.5.
yeah 22.5. 22.5, and that this makes VA 60 what? 67.5. 67.5. So you can clearly estimate a moment. From here you can get the moment diagram. I will not get into that. I think that is the basic the moment diagram. So at the end of the day, make sure okay, you can ask still, but I think that should be easy, fairly easy. So the so actually you can calculate the okay, let me just let me have mercy on you and try to go slowly. Now this okay, this is a not moving as fast as I'd want, but anyway. So once you okay, let me go slowly because I think some people might be sorry, no, that's a pin. So we've seen that this is VA. This is 67.5, point 5, 67.5, and this is 22.5, and we have this is 3, this is 30. So those who actually I'm doing this, taking all this trouble to tell you how structures is very easy and makes uh, pretty easy actually. So you draw this and maybe the here. So if you are to draw the shear force diagram, this goes to 67.5, 67.5, and then you go straight down to 67.5, then you go straight down to 22.5, 0.5, then it remains at 22.5, and then goes back to 0. Now you can calculate this distance as I told you already how to calculate that. That's 67.5. 67.5 equals 30x. 30x. That makes this I think 2.25. 2.25. Now from this you can draw. I think now that makes it easy. No need to waste a lot of time there. 2.25. So from here you can get the bending moment diagram of this structure, which okay. Let me clear because I don't have a lot of leeway. So at the end of the day, the bending moment diagram, but you should load the conjugate beam with the bending moment diagram. So the bending moment diagram would be something like this. Take care of the salient values. Where there was 0, the 2.24.5, that is where you have your maximum bending moment. If you calculate, that would be 75. 0.99375 over EI. That is the bending moment diagram. No. I think something is not right. Okay, let me draw it here so you can see. So we know that for the straight line, the load was a constant. Was a UDL. So the shear force was a straight line. Now this has to be a square, not a square, but a curve. But there is a place where after you reach this point where this was 3 meters, then it has to be a straight line because the shear force was constant. So from there, we have a nice straight line. So please note that this is a straight line. Anyway, this is basic. I'm getting into basic stuff that you should already have known. So that's a straight line, very difficult to draw. And the maximum, of course, the maximum the maximum is about and the maximum occurs at the I think, let me try to give it a better representation. Not at 3 actually. The maximum bending moment occurs at the place where the shear force is 0. So to capture it, maybe it goes maximum there and then goes it's still a curve up to this point, up to the 3, and then now from there it becomes a straight line. Now this is at this point, this is 67. No, not 67, sorry. This is 75.9.375. over EI. Now this, you can see, if you are to do the diagram for this, if you are to integrate, of course you integrate, it's gonna be a little complicated, but still, as you notice, the solution would still be easy. So you need to do two things first here. That because we need to use this some of this in our solution. So uh, to to do what? First, you need to find the center, the okay, the equation, the solution to the equation, because eventually you will need to solve the slopes here, the slope down here, and the slope there, of course, which are related, but it's easier to use the equation of uh, the equation of the curve. Now we know that this is 2.25. Okay, let me use a different pen. 2.25. Now this equation is a curve where y equals ax squared plus bx plus c. All right. Now this, if okay, let's not use y, but let's use some other function. Let's call it m. So if we start here, that's the function. So at the start, then this function is 0 because x is also not 0. So this is and everything depends on x, then it means c is 0. So there is no constant. So that is solved. So but so that's at 0. But at x equals 2.25 meters, then the function is 79. No, not 79, sorry. Is 75.9375 over EI divided by EI. So from this one, you've known that C is 0, A, and then also actually you can calculate the value at 3 because you have the VA here. You can also calculate at 3. So also the so this is one to find. So you substitute in this equation, you have one equation. Then at x equals 3, you can also get the moment there which would be actually 67. Okay, let me just explain. The moment at 3 would be the point 67.5 times 3 minus 30 times 3 times 3 over 2. That would be the moment at point 3. You can calculate that for yourself. So then, so at x is equal to 3, the function also gets 67.5 over EI. Okay, over EI. So again, you substitute there. Then you have two equations for which you can solve A and B. Now, A becomes A is, sorry, A is negative 15 and B is 67.5. 67.5. Now this is a shape thing because now you know the function of the equation, which is negative 15x squared plus 67.5 7.5x. That is the function of the m over ei diagram. Now if you would like just to remind you a little bit also, this is your it curves somewhere and then becomes straight. So if you want to find the centroid, is simply the integral from 0 to L of 15x squared plus 67.5x x integral sorry, difficult to write. Let's see. I think this is maths, so it should not be a big issue to you. X into 15x 15x squared plus, yeah. So once you solve this, that integral, and of course you know the area times the x bar should be the same as this, but the area is again the integral of this equation. So the area here is the integral from 0 to 6. Okay, the straight part is just 0 to 3, so should not be a big issue, because the linear, we are talking about only the curved part is the most difficult. The other one is just linear. It's very difficult to very easy to deal with. So 0 to 3 is so you integrate 15x squared plus 67.5. Anywho, you get the area. So from here, I'm just trying to show you the x bar. The centroid is about 1.8 meters. And the centroid, I don't know that is important, but I think maybe it's gonna be useful. So that is the only difficult thing in that part. And now to solve the theta A, the so to get theta A is simply, I think the centroid is important because the principle is the theta A. Theta A is the reaction. If you remember the principle of the conjugate beam, is the theta is the reaction at point A, actually theta is VA, right? So how do you do that? And actually it was possible, it should have been it should have been you should have actually uh, all this is important actually, because you need uh, to know them. So at the end of the day, uh, so this is what you are doing. So this is the M over EI diagram. So we are saying, so this is A and this is B. Now this, you should know that theta A should be the VA, the reaction at A of the M over EI diagram. That's it. So how do you do that? Uh, so if for example uh, you were to take moment at so let's say moment at point B, some moments at B. If you some moments at B, then this is VA. That's what we need. That would be -6. Uh, assume that's that direction is the -6 VA, 6 VA prime, plus now the load. So we were loading this with the VM over EI diagram, if you remember, and just not to forget 75.9375. Now to find the equation of this curve is easier, because now to find the area, because you can see this shape is a little complex. So to find the what do you normally do? Find the area times the distance to the center. So the area of this, the centroid of this, we found already to be about 1.8 from the 1.8 from this end. That means to the point where it is 3 is 1.2 meters. That's why actually it was important to get the equation, and to this point is 3. And the area from, if you do your integration well, the area is about 168, 168.75 over EI. Sorry, the internet seems to be misbehaving a little bit, but so now times 4.2, because 1.2 plus 3, so that becomes 1 variable, and then in fact that's the only plus, sorry, plus now, because now we've dealt with the difficult one, then the straight part is half times half times 3 times 67.5 over EI times the centroid is 2/3, sorry, okay, EI times 2/3 of 3, which is just 1, 2/3 of 3. Okay, so that gives you VA as VA prime as 151 .875 875 over EI, of course, based on the so if you know this, you can find the area of this plus the area of that should be the same as VA plus VB. So from there, then V prime B would be 118.125 over EI. So you find you have the thetas basically. So this is same as theta A, and this is the same as theta B. So I think that the only tedious part was the first one. The second one you use basically the conjugate beam method. So I try to make it simple for you. Excuse me. So actually, if we now go to the redundancies, yes, someone has a question. Hello, you're breaking. Yes, I can hear you. Yes, to find VA. Yes. What is the problem? What exactly is the problem? Summation of moments at B, right? If you sum moments at B, what does that mean? Negative 6 times VA, right? Yes? Hello? Yeah. And then someone is trying to explain to you. We take moments at B, and this is the area which you can easily find from the equation that we be able to find. Or if you have any other way to find it, I think it's better with the equation. It's easy. It's much easier with the equation. Yeah, and then from then okay, that was maybe the part you would think is very involving. The rest I think should be fairly easy and straightforward. So if so this is the initial so we are now applying the redundance, but to help us apply the redundance, you apply a moment 1 at the place of the redundant. Then now you apply that, you multiply the moment times the redundant. Now if you do that, if you're a good student of structure, you realize that the moment will go up here once and then go back to 0, and that equation would simply be 1 minus x over 6, and now to get the alpha AA, uh, If you remember, to get because this is to get a deflection at that point due to a unit moment, you impose so this, because we are doing this at a, the definition would be alpha aa, and this would be m over ei. You impose the diagrams like that and then integrate, right, from 0 to l. So this would simply means from 0 to 6 of 1 minus x over 6 squared. Now, I hesitate to get into a lot of maths. That should be for you. So alpha AA should be 1 over E. Okay, I'll try to be a little magnanimous. EI into after, okay, no, this is, okay, let me try to be magnanimous a little bit. Alpha AA would be the integral. Now let's factor this out. EI over, if you open that equation, x over 3 would be 2x. If you remember, I don't know whether I teach you math. This is squared. You already know how to do this, right? This is 1 minus 2x over 6. 2x over 6. I think you should have already learnt this in math. 2x over difficult. Okay, 2x over 6 plus x squared over x squared over why is it 30? Oh, this was 6. Sorry, this was 6 over 36. You should already know that. So in fact, let me just go straight to the answer. Alpha a would be integral 1 minus x over 6 over 3 plus x squared over 36. Your good integral, you can integrate, that would be x minus x squared over 6 plus x cubed over I think x cubed over 108 x cubed over 36 times 3, of course, from 0 to 6, from 0 to 6. Just a minute, that's x cubed. 6, yeah, so that's correct. So therefore, so here you find alpha AA. If you solve, you find this is 6 minus 6 plus 2, and then alpha AA is actually 2 over EI. Without doing a lot of, if you want, you can repeat for alpha BB, but you'll see by common sense alpha BB is the same because the geometry remains fairly the same. So alpha BB is also 2 over EI. That said, alpha AB is alpha AB Okay, let me go back a little bit to make sure you understand. So so we apply a moment there, so that this is 1 minus x over 6. But so if this is your conventional, right? But if you apply it here, if from the view of this guy here, no, 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 here, from here, the from here the equation is x over 6. In fact, if you are viewing in that direction. So similarly, the alpha AB or alpha BA is the same as integral from 0 to 6 of x over 6 into sorry times times 1 minus x over 6. You can do what the okay, this 1 over EI, the solution alpha AB, which is alpha BA, should be give you x squared, x after you integrate x squared over 12 minus x cubed over 108 from 0 to 3. That will give you actually alpha AB, which alpha BA is 1 over EI. So you've solved the two things. I think I'll the rest now I can leave for you because it should be very easy. So alpha AB is alpha BA, and then these two equations. You remember these equations here? These equations, because you already have alpha A, this you solve, this one you have solved, this one you have solved in terms of MA and alpha A. Sorry, I think that's the wrong one. You've solved this one, and you've solved this one. You have also solved this one, right? You have also solved this one. You have solved this one. You have solved this one. So you know only don't know this, don't know this, don't know, and two equations and two unknowns, which you should be able to solve. So I'll just write the equation for you here, and then make sure you're able to solve. I've gone through a lot of trouble to try to demonstrate to you that it's very easy. But just so you have uh, the the confidence, and so actually, if you follow this, uh, should be very easy. Should give you confidence of being able to solve. So that many students think that this is very difficult, but if you follow that example, you realize it's very easy. In fact, this is one, maybe probably one of the most what we might consider the most difficult. So plus MA into 2 over EI plus MB into 1 over EI. This is equation 1. This is one of the equation. Equation 2. Equation 2 is 118.125. And the first thing you see there that EI is going to disappear, plus MA into 1 over EI into 1 over EI plus MB into 2 over EI. So you have two equations, two unknowns you can solve for MA. Once you solve for MA, I mean it's should be very easy to solve the rest, unless there's a question. I think that was the probably what I'd say the tricky bit, but the rest should be very easy. Unless there's a question. I was trying to record this. Now that we moved, I'm not sure how good the quality is. If you're lucky, maybe I'll put it online to watch, depending on how good the audio is. Question? Have you understood? Then we can stop the class here. I'm not sure if this someone is saying I sent you, but I've been recording and trying to show you. I'm really not sure of the. The only thing I can say is the to this person asking. To this person asking, the only thing I can tell you is this is my way. I don't know in the notes if this is the same way working method. Might be a little different. And that's the first thing. Number two, I'm not sure if the recording is good. Then I can put for you so you can see how to work. Now, someone is saying they have not understood fully. Please ask a question. That's the only way to know if you have understood. Ask. Someone please ask. Baridi is saying that they are not sure whether they have fully understood.